IGBTs or insulated gate bipolar transistors. An IGBT combines the advantages of BJT and MOSFET. An IGBT has the high input impedance similar to MOSFET and low on-state conduction losses like BJT, but there is no secondary breakdown like BJT. By the chip design and the structure, the equivalent drain to source, that is RDS resistance, is controlled to behave like a BJT. Now this is a cross section of an IGBT. This is identical to that of the MOSFET except P plus substrate. And the performance of the IGBT is closer to BJT rather than the MOSFET. Now this is due to the P plus substrate, which is responsible for the minority carrier injection into N minus region. These are equivalent circuits, and further this equivalent circuit is simplified like this. An IGBT is made of 4 alternative PNPN layers and could latch like a thyristor given the necessary condition that alpha NPN plus alpha PNP is greater than 1. Then N plus buffer layer and wide epic base reduces the gain of NPN terminal by internal design, thereby avoiding latching. And we know that BJT is a current control device and MOSFET is a voltage control device, and IGBT is also a voltage control device, and it has a lower switching and conducting losses while sharing many of the appealing features of power MOSFET such as gate drive, peak current capability and ruggedness. A switching speed of IGBT faster than BJT and inferior to MOSFET, and this is approximately 9 to 10 nanoseconds, and this is 0.9 nanoseconds, and this is in between 2 nanoseconds. The symbol and the circuit of an IGBT switch. The 3 terminals here we call them as gate, emitter and collector instead of gate, drain, source of a MOSFET. The parameters and the symbols are similar to that of MOSFET, except that the subscripts for source and drain are changed to emitter and collector respectively. The current ratings of IGBT 400 amps and 1200 volts, and switching frequency is 20 kHz. IGBTs are used in the applications of medium power such as DC and AC motor drives, power supply, solid state relays, etc.